AP Chem students, I was a little frozen there. AP Chem students, here is number 10 on those Ksp solubility product constant introductory questions. Got a video on the first 9, I think in 2 different videos there, but here's what's happening on 10. It's kind of a lot of stuff going on, but it's not a terribly tough question once you kind of figure out what's going on. A picture kind of helps in this question. So it's telling you you have a beaker or some kind of solution. So let's go. That's water. The concentration of KCl in there is 0.01 molar, and concentration of sodium iodide in there is 0.01 molar as well. So if we think about what's actually in that beaker floating around, you would have potassium ions and be 0.01 molar for concentration. You'd have chlorine ions, same concentration. Sodium ions, same concentration because these were the same, and some iodine ions. Okay, so those ions would all be floating around individually, and they're all the same concentration. So, if these two run into each other, nothing happens. They still dissociate. If iodine runs into a potassium, nothing happens because potassium is always dissociated. If these two run in together, nothing happens because sodium chloride always dissociates. So none of those are going to cause any kind of precipitate. They would just keep, everything would stay dissolved as you're going through there. They're going to add some AgNO3, probably just some solid AgNO3. And this also dissociates. So now we've got some silver ions floating around and some nitrate ions floating around. So now we've got 6 different ions floating around in solution. And we know the concentration of these 4 ions. We don't know the concentration of these because we're just adding in some solid silver nitrate. We don't know the amounts. Well, if we think about things that can form precipitates or cannot form precipitates, I know that potassium ions will never form a precipitate. I know that sodium ions will never form a precipitate. They're always soluble. And I know nitrates never form precipitate. So let's get rid of those. So now things we have left, we have silver, chlorine, and iodine. Well, silver chloride is not very soluble, and silver iodide is also not very soluble. They also give you KSPs for those, so you know that those 2 things can possibly form precipitates. So as you start adding in this in, we can get a precipitate of AgI as a solid down here, or we can get a precipitate of AgCl. If we add enough, we're probably going to get a precipitate of both of them. Just looking at these KSPs, you notice these ions or these compounds both only have 2 total ions in them. If you look at the KSPs, it wants to know which one's going to precipitate first. Well, this has got a much smaller KSP than this one. It's way smaller number than this is. So this one will precipitate out first. It's going to, remember, these 2 concentrations multiplied together cannot go beyond that. So I know the AgI will precipitate out first. If I write my little KSP expression for AgI, I would write my KSP equals the concentration of silver ions to the first power times the concentration of I negative ions to the first power. So I know that these 2 molarities multiplied together cannot go above the KSP. Let's plug in the KSP, 1.5 times 10 to the negative 16th. Sorry, negative 16th power. These 2 concentrations can't go above this. This already has a concentration. The sodium iodide was 0.01 molar, so that means the concentration of I negative ions was 0.01 molar. So I'm going to plug a 0.01 molar in for that. That's already in solution. Okay, it was already in there before we started adding Ag ions to it. Let's figure out what concentration of Ag ions we can put in there with that much iodine. So with that much iodine in there, we can't add much Ag before we get to this number. Okay. You would not be able to add very much before you're going to go above the KSP value. So divided by 0.01, our concentration of Ag ions would be 1.5 times 10 to the negative 14th molar. You wouldn't be able to add much. You'd add very, very little of this before you start seeing a precipitate. That's a very, very small concentration that you can put in. So as soon as we hit that concentration of Ag, we're going to start seeing a precipitate of AgI.